Welcome to our introduction in Algebra 1 to radicals. We are going to be, I'm making a note up here about how you've talked about Pythagorean theorem before. That's probably come up in a math class before, but if it hasn't, that's not going to have anything to do with what we do here. So we're going to talk a little bit about perfect squares, breaking down radicals. First thing you've got to be able to know when you're doing these is your perfect squares. And again, we'll be talking a lot about these. Again, squares or exponents with these. Taking something to the second power means we take that number and multiply it by itself. Okay, in this case, that does not mean that 3 times 2 is 6. It means 3 times 3 is 9. 4 times 4 is 16. Okay, 5 times 5 is 25. Oops, I kind of moved the paper there a little bit on us. 6 squared is 36, 7 squared is 49, 8 squared is 64, we have 81 and 100. These are the basic ones that we're going to be working with. But it's these numbers that are going to be the key to us being able to break down these radicals as we work along in this section. Okay, breaking down radicals will come in handy when we're solving equations, when we're doing some things in the future with other radical expressions in the Pythagorean theorem. So when I go to do this, and I'm going to try to keep my magic numbers here on board, okay, we're taking a peek and we're wanting to find the largest one for each of these. And if that doesn't happen, well, that's going to make this a little bit trickier. So without further ado, let's get down to business here. So when we go to break down a radical, we look for a perfect square, one of the numbers we just got up here above, in the squares, and see if it divides in evenly. If that's a tricky thing for you, we may have to go to the calculator for some of this, but we're not going to go to just decimals. We got to find the largest one, and we have to do it more than once. So when I go to break these apart, I'm going to have 2 square roots. One of those square roots has to be a number up here that's going to help me out. Now, 1 doesn't do a whole lot for us, so we're going to kind of cross that out. So which one of the numbers up above divides into 45? If you're not sure, start with some of the larger ones and just divide them into your calculator. Maybe you try 45 divided by 25. You find out you get a decimal. It doesn't go in evenly. So maybe you try 16. Nope. But you get to 9. You're like, ooh, 9 goes in. So 9 goes in, and 45 divided by 9 is 5. Or 9 times 5 is 45. Here's the last part, and here's the part that gets a little tricky. So I have a little trick to help you with this. I like to look at this as though these numbers are in radical jail. Well, 9 is being perfect. So because of its perfect behavior, 9 gets out of radical jail with a new identity, 3. 5, however, is still acting irrationally. Math joke. 5 has to stay in radical jail, and I'm done. This is the simplest form of that particular radical. That's how these are going to work. Now for a second, I'm going to jump down to 4. I'll come back to the other two in just a second. I'm going to bump this up a little bit. Hopefully you've written yours down by now. Okay, 48. Again, think the biggest one that might go in. Okay, good. 16 will. So we'll have 16, and when we did 48 divided by 16, we got 3. Because these two numbers always have to multiply to get the number we started with. And again, just use the rule that we just talked about. 16 is perfect. Okay? It gets out of radical jail. Square root of 16 is 4. Because these work backwards as well. Square root of 16 will get me the big number. Square root of 25 will get me the big number here, my base number. And then again, 3 still acting irrationally stays in radical jail. Now I wanted to do a couple more normal ones before we got into the one that's a little bit trickier. So what we're going to want to do is take a peek here at example 2. I'm going to break this off because I'm going to look at it a couple of different ways. Some of you may look at first and go, okay, let's see here. 9 and 8, you may think. You're like, okay. So if I got the square root of 72, let's say I do 9 and 8, because 9's in my list. So square root of 9. 9 times 8 is 72. You're like, okay. Square root of 9 is 3. 8 still being irrational, and I'm done. Now maybe another one of you sits there and goes, well, wait a minute. I didn't do 9 and 8. I did 36 and 2. So let's see what happens when we do 36 and 2. Square root of 36 is 6. Square root of 2 is 2. Well, wait a minute. I'm not getting the same answer. What's the deal here? You know, what's happening? Well, what's happening is if we take a look back at the first one that we did, and we take a look at that 8 that's under the radical, and I look at my list again, 4 will go into 8. This may get a little tricky. So let's break this off again. So I got the square root of 4 and the square root of 2. You're like, well, what happens to the 3? 3 is just kind of hanging out here for a minute. We're just dealing with the 8. Square root of 4 is 2. Gets out of radical jail for being perfect. 3 is still out here, and now I can multiply the numbers that are free or that are perfect. And I get the same answer either way, but that's a lot of work. So that's what I mean when I say you've got to take the largest number and take that out as one of your factors. Otherwise, you may have to do this a couple of times, okay? So when we get over to example 3, we start going through again. Again, look for the bigger numbers first. I know that 4 goes in, but there's a better one. Take a minute, think about that. 64. Okay, even 16 goes in. You're like, dang, sometimes there's quite a few choices, and there are. But you've got to make sure we got to really work getting that bigger one, because otherwise we're going to have to do it more than once. Square root of 64 is 8. It's just my base number. Square root of 2, and 2 is not going to break down anymore. Really pays to take a minute and look at this. What other things could I possibly throw at you? Well, if we move down a little, and hopefully, again, you've got your list, because it's going to kind of disappear off the screen. 2 square root of 80. You're like, now what's up with this? We're going to ignore the negative 2 for right now and just deal with the 80. So again, I'm going to start dividing numbers in, the bigger the better. So I'm like, no, 64 doesn't work. No, 49. I'm getting a decimal when I punch it in my calculator. No. Oh, 16 works. So 16 and 5. Now again, that 2 is just lurking, that negative 2 on the outside. We're not doing anything with it yet. Square root of 16 is perfect because it's one of our numbers from up above, which is 4. And now the two numbers that are outside can be multiplied together. And I'm done. Okay? So we always ignore that number on the outside until the very end. Now the last two we're going to take a look at here are number 8 and 9. Okay, example 8. 8's a pretty small number. Well, 4, luckily, is the only one that's going to go in here. And I just want to make sure we don't do something that I see an awful lot. So I do this. My 4 is still on the outside. Square root of 4 is 2. And sometimes people want to end up taking the square root of this, but this 4 that's been hanging out here is called a coefficient. That's not needed to break down. It's not in radical jail. So now these two that are out of radical jail can be multiplied together, and we're good. Example 9, I look at 21. I'm like, 21. Well, 16. Nope, I get a decimal. 9. Nope, I get a decimal. 4. Nope, I get a decimal. Sometimes we maybe get one that's done already, so you have to be careful of that, okay? We're going to be doing this for a couple of days. If you got questions, ask. But if you're not sure, maybe run through this one more time just to be sure.